Okay, this is Friday. We're going to be doing DNA probes for the different mycobacterium. Yesterday we ran parasequencing. Anything that didn't work on parasequencing, we have probes to rule out Mycobacterium tuberculosis, MAI, Mycobacterium gordoni, and if we think we have a Mycobacterium cansansia, we have a probe for that. So we can only rule out those particular ones. Parasequencing will go ahead and key out any mycobacterium. So anything that didn't work, we will still try to rule out those particular ones. Now, what we have here, specific colored probe tubes. The red ones are for MTB, the green ones are for MAI, and the yellow ones are for Mycobacterium gordoni. There is a single-stranded DNA with a chemoluminescent tag in each one of these specific for that organism. Now, what we're going to do is we're going to process the patient specimen in these particular tubes here. These are lysis tubes, which have little beads in here, and we'll put some specific buffers in there, and then we'll be going through a series of steps where we're going to sonicate first, then we're going to heat, and that's going to break up the organism, release the there's a single-stranded ribosomal RNA that's going to be released from these organisms if they happen to be there, and they will form a complex with the single-stranded DNA. And if that happens, when we read it on the machine upstairs, a flash of light will be given off when the hybridization occurs, and when they bind, and then it'll give us a reading, and so we'll see that. So what I'm going to do right now is just add some reagents. I have some reagents that I have to add, and then we'll go ahead and we'll add the patient specimen to these lysis tubes. We also have control organisms that we have to run. For the TB probes, our positive control is Mycobacterium tuberculosis. And this is our positive control for MTB. This is Mycobacterium tuberculosis. Our negative control for the TB probe would be Mycobacterium intracellulare, or Avium intracellulare. We call it MAI. That's our negative control. Now for MAI, it will be reversed. MAI, Mycobacterium Avium intracellulare, will be our positive control, and TB will be our negative control. And then for the yellow tubes back here for Mycobacterium gordoni, our control is Mycobacterium gordoni, and the look-alike, Mycobacterium scrofulacum. So by looking at them, they look the same, but the probes are smart, they know. Okay, so what I'm going to do now, I'm going to add 100 micro lambda, or 0.1 mLs of our reagents. Now, the way it works out is we have a reagent 1 and a reagent 2, and I keep this on this block because it keeps it in solution, the heat does. If it's a liquid media, and our patients are all from midget tubes. Okay, so that's all liquid media. So what I have to do is, if it's a liquid media, I don't need to use reagent number 2 because the liquid will take the place of it for volume. If it's a solid media like our controls here, I'll have to use reagent 1 and reagent 2. Alright, now we're going to add our controls now. So for our TB control, our first tube will be MTB. Okay, time to add the patient specimens. And so what I'm going to do now is add 100 microlambda, just like we did of the buffers. We're going to add that much to each one of the probe tubes. Okay, now the next step is to vortex these, and the vortex machine is right over here. We're going to vortex these things for about 10 seconds. Okay, now the next step is to sonicate these. So I have a sonicator, and this is going to go for 15 minutes.
What's the purpose of the sonicating?
Sonicating helps break up the organism. I vortexed it. The vortexing helps break it up, but when you sonicate it, it actually does a better job of breaking up the organism. It kills it and also releases the ribosomal RNA. We're going to put them in our 95 degree or 100 degrees. It's got to be at least 95 or greater to kill off the organism. So this is going to kill it and break up the DNA. This will go for 10 minutes. And then when we take it out of here, after 10 minutes, we'll put them in our probe tubes. Okay, now I'm going to take out 100 microlambda out of the lysis tubes. Put it into the probe tube. Probe tubes now at 60 degrees.
For how long?
This goes for 15 minutes. We're going to add 300 microlambda, 300 into each tube of our selection reagent.
And what does this reagent do?
This selects out the unhybridized probe that we have in there. So it's selecting out everything that hasn't been hybridized. Then we're going to vortex them over here. This is kind of an important step. We want to make sure we vortex it real well. Now we're going to put these back in for various amounts of time. The TB, or the red tubes, will be incubated for 10 minutes. The green ones for 7 minutes. And the yellow ones for 5 minutes. Then we'll take them out when they're done. This is the GenProbe machine, luminometer they call it, and we will be reading the results of what we just did upstairs. Oh, Mycobacterium gordoni, the yellow tubes we're going to read first. And we have 3 patients. Okay, so we're going to hit start.
So the first is our positive control.
First is our positive control. This is our negative control. Our first patient was negative, and our last 2 patients were positive for Gordoni.
Okay.
And here's our, it says positive here. This is anything above 30,000 is considered positive.
Okay.
Alrighty,
Thank you.
that's done. All right, so it worked.